All right, so now we have a question that we took from my Prep Club's GRE forum. It is another great example of how familiarity with number properties will save you a lot of time in answering these questions. Okay, knowing the time-saving opportunities, whether that's through formulas, whether that's through patterns, rules, or tricks or common traps that you're familiar with that the test makers throw at you, knowing those is going to be crucial to getting a top grade on the GRE. So if you're looking for that top grade, you need to know this stuff off by heart. Most importantly, in my opinion, you need to know your number properties. The ultimate GRE cheat sheet has 160 pages of formula, rules, tips, tricks, patterns that you can use to save time on questions when answering the GRE and the quantitative reasoning section. And you absolutely need to know this stuff off by heart if you're looking for that top grade. So just to kind of illustrate my point, you could look at this question, right, and think picking numbers would be the best way to answer it. Because, I mean, you're told that A is a positive fraction. You know that A is a positive fraction, okay? And you know that B is a positive number, B is positive, and you actually know that B is greater than A. That's what the question is telling you. Now, you could pick numbers. You could say A 0.5 or a half. You could say B is 2, and then you could systematically plug those numbers into every single one of these answer choices and then check which one's the biggest. Probably take you a minute. It's not really hard, those computations, but it's just time consuming. A much faster way would be to not do any computations whatsoever and just rest on your understanding of number properties. There are some number properties I want to tell you about today. The first one is that big over small, okay, is going to be always greater than small over big. That's the first one. The second one is that a fraction raised to an exponent will always be smaller than the fraction itself. So a fraction in this case, a positive fraction raised to an exponent, so a positive fraction, don't forget that, a positive fraction raised to an exponent, call it 2, well, actually let's call it p, will always be smaller than the fraction itself. And that's another reason, just to go back to this positive point, that's another reason why I'm not actually a huge fan of picking numbers, because unless you know exactly what it is you're trying to test, and you're really only testing like a yes or no, picking numbers is not a very efficient strategy. You're much better off using your understanding of numbers and using kind of logic and reasoning to minimize the number of calculations you need to do to find the answer quickly. If you, when you're picking numbers, forgot about the positive and there was a negative in the question, which is a common trap, you could be sat there for 3 minutes going through a bunch of different calculations to try and figure out which one's the best. And yeah, it's not that hard, it's just time consuming. So I would avoid it unless there's kind of a very simple yes/no question you're trying to solve in your analysis or evaluation. I would avoid it. The third rule is that a positive number, in this case, let's call it b, raised to an exponent, will always be greater than the number b itself. So 2 to the power 2 is 4. That's greater than 2. True. A half squared is a quarter. That's less than a half. True. Okay, so just to illustrate those points, these are the rules you want to know. Right, so let's now apply this to the question. We're told A times B as the first one. We know AB is going to be less than B. Okay, we know that's going to be less than B. Now, I won't go into detail as to why I necessarily did that. As you practice your familiarity with these number properties and as you practice solving questions without doing any, hard maths or arithmetic, you will get more confident with knowing how to reason through these questions like this and knowing how to compare numbers, what you want to benchmark them against each other with. And generally speaking, your confidence in doing this will increase. So I'm not going to go into that in too much detail here. I'm just going to show you how knowing about number properties would solve this question much faster. AB less than B. let's look at these B and C. We're told that A over B, and then we're also told B over A. Let's compare these two. What do we know? Big over small is always greater than small over big. That's small, so that's small. That's big. That's big, right? That's small. So we know that small over big, this one, is going to be it's going to be less than, sorry, big over small. So we know immediately that B is out because C is greater than B, right? So C is greater than B. And if we look at that, we have B over A. We know that a positive number, so a positive number over a fraction is always going to be, well, let's reason it through. 2 over a half, okay, equals 2 over 1 times by 2 over 1, because you flip it when you multiply, that's going to be 4 over 1, or 4. So we know that B over A, a positive number over a fraction, a positive fraction, is always going to be greater than B, right? It's always going to be greater than B. It's also always going to be greater than A. But in this case, B over A is greater than B. That immediately lets us eliminate AB because AB is less than B. BA is greater than B. Now let's look at these two, and we're going to employ the exact same technique using these number properties here. We know that D, okay, is D big or is D small? D is a fraction raised to or divided by a big number. So that is small, okay, over big. Now, what is E? E is a big number divided by a very small number, because we've actually raised the fraction. It's going to be very small. So we've got big over small again. What do we know? We know that big over small is always greater than small over big. So therefore, we know that D is out because D is necessarily smaller than E, right? So now the only answers remaining are C. So we're going to compare C to E. And C, what's C? C is big, the same, so big over small, small again. Now we have two small, so we're going to focus on A and A squared. A and A squared, what are we told here? A is always going to be bigger than A squared, so therefore we know that C has a greater, or let's flip this around, E is actually smaller, right? Therefore, C is going to be the right, E is going to be the right answer. E is going to be the right answer because the small, if we actually just cancelled out if we cancelled out the numerator, we have small versus smaller, and then we know that when it comes to big, the smaller the small, the bigger the big. That's the relationship. So therefore, we know that E is the answer.